Good afternoon, and welcome to today's Spotlight webinar, Super Fast Electrode Design and Manufacture with Cimatron. I would like to introduce you to our presenter, David Lindeman, Application Engineer for 3D Systems. With that, I will turn the floor over to David.
Thank you, Lisa. Thank everybody for being with us this afternoon. We'll endeavor to keep our presentation fairly short today, about 20 minutes. That way we have some time for questions afterward. A little bit about Cimatron. Cimatron has been around for many years and is a well-recognized design solution for molds, dies. Also, it's well known for its NC programming, so it's a very good niche for the tooling industry. Of course, one of the biggest focuses of doing mold building is the ability to create electrodes. So Cimatron has its own electrode package for design manufacturing, which we'll highlight as we go through our presentation today. With that, let me toggle on over and we'll start to take a look at the software here. So I've got a fairly typical looking B-plate, a two-cavity mold. You can tell it's a right hand, left hand. Some details, enough indeed that you need to create some electrodes to get some of those rib work done. We're inside of the electrode package now as we speak, and for the sake of time, just started the process already underway. Let's start by extracting our first electrode. You see, I'm just going to work off the wizard, or we call it a guide, over here on the right hand. And we'll target an area where we want to place our first electrode. Maybe it'll be right about here in this feature. So it begins by putting in generally an outline of what that electrode size and shape look like. You can see I'm just typing some values in. It'll keep track of the orientation. It'll keep track of the angle, or how big it is, and most importantly, the position, so that it knows from tool center, in this case, how far to bring the electrode over to drop it into position. I have picked what I want, so that's going to be the feature that I'm going to create an electrode for. So just to focus on what we're working with here, you get an idea of what that geometry looks like. Working again over here on the guide, we'll first begin by looking at the blank. There's your overall graphite size, and again, this is same position and everything. We're just going to keep track of it as we go through. The height of the graphite base, also the clearance, all that's kept track of. You can see it's easy to adjust by just typing in a few factors. Do I want a step base, a straight base? Maybe I want to do this so that I can finish all four sides and pick it up. So if I got my base well defined, we'll keep proceeding. Next, I want to start building some extensions coming off of those red part faces. So I'll do a quick zoom up, and we'll give it a size that you hopefully can see better. So right now it's working with a tangent extension based upon whatever it finds. So if there's 5 degrees of draft on those walls, those extensions will carry up at that 5 degrees. You can drive them up straight or drive them up in two directions, maybe up and out to the side hole. Each of these has the option of going a set length or all the way up to the blank, your choice, how you want to drive them. So I like that. That's a good extension to begin with. I'll apply it and immediately start building my next one. Maybe I'll go straight this time, and we'll set a specific distance. Now at min distance, basically it's bringing it up to a planar direction, a planar point, and that 100,000th is going to be the minimum value for whatever shape it happens to be coming off of. That's good. Working with the last one, let's set this to go straight to the blank. You see here, and I don't really want to take my time to cut all that. It's kind of pointless for me, so let's just use a simple step like you see here. That can be a contoured step as well, whatever the choice may be. That looks good. We'll say okay. So very quickly we've built the extensions that we need for creating that. We'll go grab a holder. Now there could be several different types of holders, and here I'm working with some Aero 1mm holders. We have 3R holders, and you can create your own holders or download a library of them, whatever the case may be. Position that as we need to. You can see things are coming together. Let's create an electrode coordinate system, which when I show this to you is basically going to be the pickup point. You see it here on the back of the graphite, or it could be any of these positions that we want. So whatever your shop standard is for, where you're coming from to set your location, you can use that. And then likewise, while I'm at it, let's set a pickup for NC. So if I'm going to take this to a CNC machine and cut it, I'm going to start maybe top of my geometry, which you see highlighted there. So quickly we got our references that we need. All that has been established. If this is the methodology I'm going to use again and again, then I might as well save this. The process of how I've gone through building this. So I'm going to save it as what we call a template. And of course, I'm real good with these names, so we'll give it a name that we can find easy. Okay, call it new template perhaps. And let's go on to creating our next electrode. Go back to our plate that we're working with. The thing about the use of the template, it doesn't necessarily have to be working with similar geometries. It's the method that you've used that's the most important. So perhaps we'll zoom into this area down here, strike a position that we want, and from the template, let's say what we want. Well, new template, there it is. We'll go ahead and use those faces and create the electrode. So it remembers the sequence of events that we went through, all those steps, and then reproduces them on the next electrode. Kind of nice that you can create this little simulation. All right, it's a good way to check to make sure your clearances are good. And you have the ability, too, to create a trajectory. So maybe I'm burning a feature where it's going to be a subgate. I'll bring the electrode down to position that I want to move it at a 45-degree angle into the steel. It'll let you do things like that. I've seen electrodes that come down and burn in sideways. So that's another way. We may use the trajectory and then simulate to make sure the motion is what we think it should be. Okay, so we've got those two done. Let's illustrate what I meant by saying it doesn't necessarily have to be the same exact geometry. So I've got this rib down here at the bottom on the left-hand side. And let's address it this way. We'll go ahead and pick where we want that to be. And looking at it, you can see I could get a lot better use of my graphite. Instead of trying to drag it and move it and size it, if I could line it up to what that feature looks like. I don't know the angle, so I'll just pick a reference line and say, align yourself to what you see here. All right, so there now I've got the ability to take it, and as I move it or create a different, or make it bigger, you can see how it finds that shape and gives me the best usage. Also, if I want to make sure I'm working to standard sizes, I can always use my fit and center, so that no matter how I've adjusted it, it will look at the mass of that and say, okay, that's what you want to work with. We'll go ahead and continue using the template. All the information that we just gleaned is recorded and it's going to stay with us as we go through the system. We'll go ahead and build this electrode. There's our third one. Now looking at this one, it's nice to be able to modify things because in a lot of cases I may not want to have every single feature on one electrode. I might need to use a couple of electrodes to actually burn it correctly. So in this case, I'm thinking that this little tab here, let's remove it. So just select it. It's now taken away from what I'm going to put on the electrode, but you see I've got all this graphite now that it says basically I'm wasting. I'm just cutting it off. One nice feature is those refits are always accessible. So if I've made a change, I can step right back over and say, let's just refit the height. So now it's reduced down, and the graphite I order will be graphite I use. I won't be cutting stuff off to waste it. Well, that means that little feature left behind is going to need its own electrode. So let's flip that back around, and we'll take a look at that one then. To make it easier to see, let's turn these other ones off. And we'll address this feature again. Get my position that I want. Tell the system that I don't want these particular faces. All right. So that's the one I want to work with. And again, you can center, you can do whatever you need to do. Just want to make sure those aren't picked. And then we'll go ahead and build our electrode. If you notice in this case, it tries very, very hard to get down in there, but with clearance. So however I would need to design that, I've got some very quick tools where I can hop in there and grab that particular geometry. All right, with that, let's look at something else. There's more than one way of going about building an electrode. I'm showing you the automatic quick way, but to point out that within this system is a full functioning modeler. So no matter what you run into, you can always make something yourself if need be and step through creating the electrode. Maybe in some cases you'll work on one portion of it manually and then do the rest of it using these automatic features that you see on the guide. Also, there's another set of tools that we can work with that's very, very handy. Pull an electrode using this long rib area here. All right, so again, we'll extract it, focus in, say in this area. Again, this is like a rubber band. It's going to snap to standard sizes, of course, which I can control. That's the feature I want. So again, fit it, center it, all that is done. I'm not going to use a template this time, but I'm going to manually construct it so that you can see the technique that's being used here. That will be the feature that we're going to create an electrode from. Turn off the plate again. I can see clearly what that rib is going to look like. It's this function here called burn body, which you might think of as kind of like a solid extraction or a way of Boolean cutting it. We've got different options, though, for creating how we want to do this. If I build it as a single direction, you'll see it basically cookie cutters right in there with the clearance off of those mold faces. However, to edit that, I might also look at this option of two direction, which means I'm going to come up to a set distance and come out that side to a set distance. So when we build it this way, you see now I've got the tangent extended surfaces that I'm looking for too. So it's kind of like having both of those elements right within that one function. With that, we'll keep walking through here now. Again, I'll put a blank on it. And while I'm at it, let me turn off the others so you can see exactly what I'm doing. All right, as I build this, you know I'm going to start running out of room here on the right-hand side. Say, okay, that's fine. Let's go ahead and start building some extensions. Maybe again, I want to come up tangent a certain length, put in whatever value I see fit. Say okay, and now let's go a straight direction. Again, a set length, that would be good. Finally, I want to go all the way up to the blank. And while I'm at it, maybe I want to put a step on it. As I start building that step, you can see I'm running out of room, all right, clearly. But one nice feature is to be able to go back into the blank and say, no, I'm going to refit it. So by saying refit, you see it's shifted over to the right, and you also see how it's now given itself more room. So it's very fluidic, and as you go, you just progress to the next step. It's not like you keep having to go backward and redo things. So there in just a few minutes here, we've pulled quite a few electrodes. I'll turn these back on again so you can see what we've done. All right, and like that. All right. So some nice things about this is having the ability to manage all this information. To illustrate that, I've already got a few electrodes that were built previously. When you turn them on, you can see there's quite a few at work here. A lot of detailed drawings have to be made for all these electrodes. A lot of locations have to be kept track of and then put into the system at the machine. So those are all things that we need to factor in as we go through our process here. To begin with, let's take a look at how we'd control the information as we're sending all this over to the machine. And we'll work with EDM setup. And what this does, based upon whatever machine I have, it's going to help me program it, essentially. So you might see a machine that you work with fairly often on the list, and all this can also be customized. So basically what I did is I took the Xiaomi Direct, and then I said I want to simplify it. So That way I have my own parameters in here as I work with it. Maybe I'm going to just work with one rough and one finish electrode. I can put in what type of clearance or orbit values I'm going to have, the type of orbit. Also, what am I going to be making this thing out of? Graphite, of course, and then assign the holder numbers if I want. If I wanted to have more stages, I can simply add a semi-finish, a polish, all that can also be brought in. So it's going to keep track of all the information that we've gleaned, right? The location, the burn depth, whether it was rotated, as well as organizing it for programming. Now with that, let's step over into the process here. Here I can control the order I want. Maybe I want to take that first one I did and the second one, I want those to go first, and then I want over here on the corresponding other side, I want those to go next. And when I'm content with that and I want the rest to go, I can just push all them. So you've got tools for bringing it back and forth and setting up the order as you see fit. We'll take this information now, we'll output it to our machine, and as we open it up, let's take a look at that output file. So basically it's going to give me the code that I need to program my machine. Now, this is very, very important to think about because, late on a Friday and I'm rushing to program my machine, I might come in here and put in Y positive 1.5 or Y negative 1.5374 instead of the actual number that you see me with the cursor over. That's just so easy to do, that bit of human error or fat fingering it. And all those things that happen, it crushes you. It hurts you so badly when you do that because you've got a perfect mold cavity plate sitting there, and very last step you go and burn it in the wrong location. That's just heartbreaking. Another nice thing about this is to generate an EDM report based upon the graphite I'm working with. So I'm going to take all the electrodes we've built and I'm going to pump this out to an XML file, basically an Excel spreadsheet file. So if you've got some measure of talent with that, you can customize this however you see fit. Here you see I'm ordering rough and finish electrodes, and then it's keeping account of the sizes that I need for all of that. So if I'm buying a sheet, then I know here's my cutoff list. If I'm buying those specific blank sizes from a vendor, then I can give him the list of blanks that I need. Again, all that can be fully customized. Now another nice feature, one that's very important, is to be able to document this. So here on the right click, you'll see it's got electrode drawing, assembly drawing. All right, so for the sake of time, I've gone ahead and pushed one through here, and I'll hop on over. It takes a few seconds to run this on my computer, which is just a ZBook laptop. But you see how it gathers the information and puts it on the chart. So the information that I put in on EDM setup is going to drive the information that I need here on that chart. Okay. Likewise, it's going to put in, like here, this nice ISO view, all the labels that I need, and show it to me in position where it goes over the top of the mold. All right, plus some general sizes. I didn't mess with this too much. You can customize all these views. You can customize the dimensions, the type of dimensions you want. So this is generally kind of a out-of-the-box, basically out-of-the-box drawing. With the thought of customizing in, that means you would have your own title block down here with your own username, of course, and however you would want to scale these particular trodes. With that too, let's take a look at the assembly drawing. Now this is meant to basically catalog all these electrodes. So you can imagine with all the electrodes I would have had up here, this would be turning into quite a spider web. Maybe I'll do a couple different assembly drawings, per cavity perhaps, or arrange it, stagger them so that they're not all on top of each other. Here though, you can see in the ISO view, again, it's labeled everything and it's keeping track of rotations like the one we did here. And as you can see, there's a good way of reminding you of the geometries that we pulled as we were building all these different electrodes. Okay, all that again is charted for you to work with. So very quick, effective way of getting in there, doing whatever you need. Minimize this. There we go. So this brings us to something else that we talked about, and that's the ability now to take this to an NC machine and start working with it. So you imagine I've pulled an electrode Maybe I've got more to do yet, but they're saying, we got to get going. Give us something that we can start cutting these with. With that, we'll say, okay, let's take what we got here. I'm going to work with the first one I pulled and say, let's send this over to NC. And we'll pick just that individual component that you see in red and say, okay. So a little jump right there. Now it's brought into NC, and it's asking me to pick where I want to locate. Well, remember we made that coordinate system that we said was going to be the position we'd call 0 over here on the NC table. So with that, now we brought the geometry in, got it into location. It's ready to be cut. So we'll use an utility where, again, we can apply a template. Now this is an NC template. The idea behind it is, how many times do I rough an electrode the same way with the same tool, the same speed and feed, step over, down step, save all that information, and then load it. Let me process it without having to make every pick. Again, this is a great way to avoid human error and things like that, simple mistakes. So I brought in this set of procedures, and now I'm saying execute. You can see the tools I'm going to work with and the names of the procedures we're going to generate. So nothing too much here. I'm creating a stock model that looks like this. You notice that you can be specific. I'm grabbing just the graphite, and smart enough that I can program how I want it to see what that graphite looks like. It's a nice thing that I can step into it and say, I want you to grab just the light blue cyan colors and the red faces, the red colors, and we want that to be what we call the graphite, and then ignore the purple and the gray. So that way it gives it some intelligence to know how to cut. You know, obviously I would probably not even have the holder there, but just to illustrate that you can control and avoid hitting things that you don't want to hit, or cut useless areas to cut. All right. And there's a semi-finish, maybe a quick ball end mill, wrapping down it to start to get some of that material out. Now, highlighting this one in particular, because here in the NC world, we've got the ability to program our cut based upon the orbit. So hopefully this diagram helps, or it's a 2D orbit. It's keeping track of the fact that the electrode is going to go down to the steel and then move perhaps in like a circular fashion, and it's the sides that are going to be affected. So it's the sides that need to have that gap. What this does then is it overcuts the electrode in the X and Y direction, but maintains it in the Z, which you can kind of see here in that little drawing. Likewise with the spark gap, that's going to be everywhere, all across every face of the electrode, or a 3D orbit would be similar. It'd be the same. So you'd offset uniformly everywhere. If that's the case, then I'd program with my 3D orbit here, and that's the value that you see that we brought in. So with that, you can get the electrode you need right here, cutting it, and yet also designing it with that thought and intention behind it. Okay, well, with that, we'll step away here. I don't need to save that. We'll go back out here to our main assembly. And that is essentially the gist of what we wanted to show you today. Is the ability to control these electrodes, check them, cut them, document them, take them over to the machine so that you can set up how you're going to go ahead and burn them.